Hello. Today's is being sent to you using a special type of radio. The radio transmitter is in Great Britain, over 4,000 kilometers away. Using high-frequency radio waves, the signal can travel long distances to reach you. High frequencies have long been used for radio broadcasts, but now there is a new technology called DRM, which stands for Digital Radio Mondiale. DRM is digital radio. It lets broadcasters transmit high-quality audio, such as speech and music, along with extra data. This data can include drawings or diagrams to help you understand the audio content. Today, a maths lesson. It is all about triangles and squares. We hope you will enjoy it. Simplest examples of polygons are triangles, which all have 3 sides, and quadrilaterals, which all have 4. We are going to look at triangles and about the relationship between the length of their sides and the particularly interesting, as there are several types of triangle which have special rules about them. And years ago, a Greek philosopher, astronomer, and mathematician by the name of Pythagoras discovered that there are some very interesting and very useful facts about triangles which even today are commonly used in everyday life and work. It was Pythagoras who discovered that all triangles have angles that add up to 180 degrees. But he also found some special types of triangles which we are now going to look at in more detail. The first of these is the right-angled triangle. A right-angled triangle will always have an angle that is a right angle, or 90 degrees. This means that the other 2 angles must add up to 90 degrees, because the total must always be 180 degrees. Now, in the Journalline menu structure, please go to Mathematics, Geometry, Lesson 1, page 1. You will now see an example of a right-angled triangle. The angle at the bottom left-hand corner is 90 degrees, shown by the square box in the corner, because it is a right-angled triangle. If one of the other angles is, for example, 60 degrees, what is the other? To 180. So missing plus 60 plus 30 equals 100. Journalline menu. Please go to Mathematics, Geometry, Lesson 1, page 2. This is a triangle, because this type of triangle has angles the same, working out the other angle is very easy, as again, all of the angles must add up to 180. In this example, both of the angles at the bottom are 75 degrees. So added together, that's 150. That means that the angle at the top must be 30 degrees, because as let us have a look at another special type of triangle, the equilateral triangle. This is the easiest to calculate because in an equilateral triangle, all of the angles are 60 degrees. So 60 plus 60 plus 60 equals 180. Not only that, but in an equilateral triangle, all of the sides are the same length. But we'll look at how to calculate the sides of different types of triangle a little bit later. Now, in the journal-line menu structure, please go to Mathematics, Geometry, Lesson 1, page 4. Finally, there is the scalene triangle. Unlike all of the other types of triangle that we've looked at so far, all of the angles of a scalene triangle are different. Each one of the three angles are different, but once again, they will always add up to 180 degrees. In this example, 58 plus 77 plus 45 equals 180. Now, in the journal-line menu structure, please go to Mathematics, page 5. Such as squares and rectangles, all have and 4 angles. All of the interior angles in a quadrilateral add up to 360 degrees. In a square, page 6. You'll now see an irregular quadrilateral where all the angles are different, but once again they all add up to 360 degrees. You can check this for yourself. 80 plus 94 plus 68 plus 118 equals 360. Now in the journal-line menu structure, please now go to Mathematics, Geometry, Lesson 1, page 7. Now that we have looked at the rules about the angles of triangles and quadrilaterals, now let's find out more about how we calculate the lengths of their sides. Once again, triangles have some special rules which Pythagoras discovered. The rules are called Pythagoras' theorem. Let us look again at a right-angled triangle. The longest side of a triangle, labelled C, is called the hypotenuse. The hypotenuse is always the longest side of a triangle, and it's always opposite the right angle. Pythagoras found something very interesting about the lengths of right-angled triangles and how they are related. He discovered that if he used the hypotenuse of the triangle to draw a square, C, then the area of that square would be exactly squares by the other two sides of the triangle, labelled A and B, added together. The area of a square is found by multiplying the lengths of the two sides together. So in the case of the diagram, the area of square A is calculated by multiplying A by A, which is often written as A squared. The same applies to the square formed by side B. The area of square B is length B multiplied by B, or B squared. So, just to repeat, Pythagoras' theorem states that the area of square C equals the area of square A plus the area of Pythagoras also found a special case, which is known as the 3-4-5 triangle. Let us suppose that the length of side A is 3 units, and the length of side B is 4 units. We already know from Pythagoras' theorem that the area of square C equals the area of square A plus the area of square B. Now turn to page 9